Hello everyone, welcome to today's class. We are now in chapter 3 and we are dealing with algebraic process, linear and quadratic equation. Now, mostly on this class we'll be treating quadratic equation. Now we have 4 solutions of quadratic equation. The first way to solve it is the factorization method. Second way is the completing the square method. Third is the quadratic formula. This is one they call almighty formula. Then we have the using the graph method. Let's start with factorization method. Now this is the question. Solve for 2x plus 9 equal to 5. Now, this is a quadratic equation because the power of x is 2. It can be b, it can be, but the power of the highest power of the variable is 2. So it's a quadratic equation. When you're in your lower class, when you say x plus 1 is 0, you are not being told to find x. You can now take 1 across the equation. It's positive. When it crosses the equation, it becomes negative 1. You now say x is equal to minus 1. So when the highest power of x is 1, because this is 1, you don't need to put it, it becomes a linear equation. But when it's more than 1, it's no longer a linear equation. But in this case, we are dealing with quadratic equation. We also have where the x is more than 2, is like 3, 4, but it's beyond the scope of this class. Now, this equation, when you want to solve for quadratic equation, you usually make sure that it's equal to 0. That's what I did. I now push this 5 to this side. Here is plus 5. When it crosses the equation, it becomes minus 5. Now, there's one thing I want you to note whenever you are doing quadratic equation. This x square has a coefficient, and the coefficient is called a. This x has a coefficient, the coefficient is called b. Why the constant is called c. While solving for factorization method, there is something you will take note of. You take note of b, a, b, c. So what's the big idea? First, you do a times c. In this case, our a is 2, which is 2 times minus 5, which will give us minus 10. Then our b is what? 9, which is plus 9, just 9. So you look for the two numbers that when you multiply both of them, you get this AC. Whatever you get when you multiply the AC. But when you add them, you get b. So I'm just trying, this is like I'm giving you a hint on a number. They will just solve it. Like, let me give you an example. You see something like 2x squared, something like okay, you say something like plus 10x minus x minus 5 equal to 0. If you go to any textbook, this is what they will show you. They already splitted this 9x to be in the form of plus 10x minus x. You understand? Because 10x minus x is still 9 minus 5. It's like they are writing this equation to this. Now, me telling you about this is trying to tell you the easiest way to know how to arrive to this. So the easiest way is the coefficient of the product of a times c, which is in this case minus 10, if I'm not wrong, and b is 9. So you look for two numbers. This is the two number you are looking for here. You look for two numbers that when you add them, you get b, but when you multiply them, you get this. So this plus 10x minus x, if you multiply it, you get minus 10. Mind you, this x is now added, but the main focus is on this coefficient. There's a coefficient here which is minus 1. I hope you get it. So in this case, the two numbers that when you multiply them, you get minus 10, but when you add them, you get 9, is actually 9. Okay, sorry, it's 10 and minus 1. 10 times minus 1. Please pay attention, because in other class, I might not have to go this deep in explaining it. In other examples, I mean to say 10 times minus 1 is minus 10. Why 10 minus 1 is 9? So we've achieved the aim. So you now rewrite this equation and make it the coefficient of this b. You split the b to this point. After you've done that, you now go forward and continue. You take like terms. what are the like term we can take between this and this? It's actually 2x. And we now have a bracket. 2x divided by 2x squared. You get only x. Because let's solve it. 2x squared over 2x. 2 cancel, x cancel. You are left with only x. On the other hand, 2x divided by 10x. This is 10x all over 2x. Cancel, cancel. You are left with 5. Cancel, cancel. 1. So you have minus 1. Now, what is the common thing to pick out from minus x and minus 5? It's actually minus 1. You have bracket x divided by minus 1 minus x divided by minus 1. You actually have x because minus will cancel minus. So you have x here. Then minus 5 divided by minus 1. Cancel, cancel. You still have 5. Sorry, I put minus here. This is positive because here is plus. Sorry for the mistake. So when you here you now have plus 5 or is equal to 0. Now, because both of them are the same, we pick it out. X plus 5 into. When x plus 5 divide this equation here, you have only 2x. When x plus 5 divide this equation, you have minus 1. They are all equal to 0. Now, when two products are multiplying themselves and giving you 0, there is only 3 possible conditions. It's either both of them are 0 or one of them is 0. But in the case of this equation, both of them cannot be 0 because we have a value. So it's either one of them is 0. So to find for x, you will now say, you assume this is 0. You now have x plus 5 is 0. So x is now, when 5 cross equation, it will become minus 5. This is one of the values of x. It does not mean x is minus 5. It's just one of it. On the other hand, you also say, let's assume this one is 0. It will be 2x minus 1 equal to 0. When 1 cross the equation, it becomes 2x equals to 1 because negative is when the cross equation becomes positive. So to find x, you divide both sides by 2. You now have x is 1 over 2. So when you want to conclude on your answer, you now say x is equal to minus 5 or 1 over 2. This is the first example. Now, there is a shortcut I usually use whenever I'm solving for this quadratic equation. Now let me show you something. Coming here, this is my own personal shortcut and it's always true. So you can take note of that while solving. If you have a quadratic equation, let me use like ax plus b x plus c. Remember I said the quotient of x squared, sorry, this is x squared, is called a. Quotient of x is called b, while c is a constant. This is the first scenario. Let me have another scenario like ax squared minus bx plus c. Let me have another scenario of ax squared plus bx minus c. There's something I have realized over the years that is working for me. When you are looking for this number that we looked for here, when we say the two numbers that when you multiply them, you get AC, and when you add them, you get B. What we did here. When you're looking for those numbers, if you look at these signs here, you see that this is a case where both of them are positive, and this is also a case where one is negative and the other one is positive, and this is another case where in this case B is negative, C is positive, and in this case B is positive, C is negative. So when you're looking for those two numbers, there's something I observe. In a case where both B and C is positive, like B and C is positive, because when you're solving for quadratic equation, A is always positive. Even if A is the question you are giving, A is negative, you multiply it by negative, make sure that A is always positive. So that's why I'm not talking about A. So in a case where both B and C are positive, the two numbers you look for. So when you want to change the coefficient of b, both of them will be positive. Both will be positive. As I'm solving, I'll be proving this for you. In a case where b is negative and c is positive, in that case, both those two numbers you use to factorize. This only work for factorization, please. It also work for quadratic formula and the rest, but let's stick to factorization. In that case, both will be negative. But in a case where b is positive and c is positive, now in that case, big number, the bigger value will be positive, while the smaller value will be negative. This is like a check and balance when you are solving, so you don't make mistake. Because you know when you are solving mathematics, positive and negative sign usually cause a lot of trouble. Let's come in this our case. This is our case here. We have, what is the equation? 2x squared plus 10x minus, sorry, this is not the question. What is the question? 2x squared plus 9x minus 5. Now when we wanted to split this into two, look at it. Here is positive and here is negative. Remember what we said here. When here is positive and here is negative, the bigger one will be positive and smaller one will be negative. Look at what happened here. You see that the two split I did, 10 is the positive one. Look at where I splitted it. 10 is the positive one, while 1 is the negative. Still confirming what I said. The big number will be positive and the smaller number will be negative. So as I'm solving more example, I'll always be coming back to this to reflect it. But this is just for you. It's just like a hint. If you can always find the two factors by yourself, you don't need this. But this is like a guide, a hint. So let's go to the next question. So this is the second question. Now we are now in exercise 3A. So this is exercise 3A number C. We have p squared minus 10p plus 25. Now, what is A here? A is equal to 1. Coefficient of p squared, which is 1. What is B? B is equal to minus 10. What is C? C is equal to 25. So AC, that's A times C, is 1 times 25, which is still 25. While B is already minus 10. So we are going to look for two numbers that when you multiply those two numbers, you get 25. But when you add them, you get minus 10. So the two numbers are minus 5 and minus 5. So you can check out minus 5 times minus 5 will give you plus 25, because minus minus is plus. While minus 5 plus minus 5 will give you minus 10. This also proves what I just said up here, because in this case B is negative while C is positive. Look at it here. In that case, they say both will be negative. So this is like a guide. When you want to look for those two numbers, you can use this to guide yourself for those that need it. But what I do whenever I'm teaching you, anything I know that is working as a shortcut for me, I bring it here. So let's solve the equation. Now we rewrite this 10p to p squared. This is equal to p squared minus 5p minus 5p plus 25 equal to 0. So this is equal to, we now start taking like terms. Here, the like term is actually p. So I'll take p. P squared divided by p, you have p. 5p divided by p, you have minus 5. Here, I'll also take, I will take 5 plus 5. I'm not wrong. I'll take minus 5. Sorry. Take minus 5. If I take minus 5, I will have minus 5p divided by minus 5. I will have p remaining. 25 divided by minus 5, I'll have minus 5 remaining. Equal to 0. So these two are the same. So you have p minus 5. In bracket, you bring out these two, p minus 5. I hope this thing is not confusing you. You know, when you are factorizing, you make sure that the two things and the bracket are the same, so that you can easily factorize it back out of this form. If I have used, let me say I use plus 5p here, I will have 5. Because if I use plus 5p here will be minus p, and here will be plus 5. In that case, they are no longer the same. And coming out here, I will still have, let me show you what I'm trying to say. Let me say this is already, I bring out p here, and I said 5 minus p in that case. Then let me say I use plus 5 here. So this is the one I want to check. Minus 5p divided by 5, I will have minus p. Then 25 divided by 5, I have plus 25. In that case, they are no longer the same. So that's why I have to use minus 5 here, so that when minus 5p divided by minus 5, I will have p that is positive. And when 25 divided by minus 5, I have minus 5. You can always check it. 25 over minus 5. Cancel. The minus sign is still here because plus divided by minus is still minus. I have minus 5. So when you are factorizing, make sure that what you have in this bracket are the same. It's very important, so that when you now bring out the like term, which will be the bracket, and then bring out the coefficient in the other bracket. So this is the case equal to 0. In this case, you have p minus 5, p minus 5. So you can just, they are the same. No need to say solve for this and solve for this. This is just one thing you are solving for. P minus 5 is equal to 0. So p is 5 when 5 crosses the equation. This is your answer. This answer is just one answer. And while we are getting all these questions, you can always confirm them and say, because this is our final, this is the first equation we are told to solve for. You can always say, oh, let me confirm if truly, if I use p as 5, if this equation will be 0. Let's try it. This is p squared minus 10p plus 25. If you put 5 here, you have 5 squared minus 10 times 5 plus 25. We are trying to prove if it is equal to 0. So 5 squared is 25. 10 times 5 is 50 plus 25. So if you check it, 25 plus 25 is 50. 50 minus 50 is 0. The same thing applies to this equation where we said x is equal to 1 over 2. Okay, sorry, x is equal to minus 5 or x is equal to 1 over 2. If you take these two solutions and put inside this our first question we are asked, you'll find out that you are getting, okay, like converted it to 0, you'll find out that your answer will still be 0. Even if you put it here, you'll find that the answer will be 5. So, as I said earlier, mathematics is logic. You are not just solving for solving sake, we are proving logic. So let's do one more example. I'll try to target the one that will have, I think we've done for this. I'll try to target the one that will have plus here, so that I can prove this final theory that I told you. So this is exercise 3A, number D. We're already in exercise. So I have this. What is my A? My A is 1. My B is 8. And my C is 16. As you can see, this is plus and plus. Now, what is A? A times C is 1 times 16. That's 16. While B is 8. So I'm going to look for a number that when I multiply the two numbers that when I multiply them, I get 16. But when I add them, I get 8. So that number is 4 and 4. 4 plus 4 is 8. 4 times 4 is 16. Now you can see it's positive 4 and positive 4. This proves the last theory I told you. So with these examples, I've been able to ascertain that this always work. Though you can say, oh, how can I know? Just with these three questions. Try it in as much question as you like. Find that it always work. And you can use it as a hint to know when you are getting it wrong, especially in that initial stage where you are looking for those two numbers. So let's continue. In this, I will now rewrite this equation here as y squared plus 4y plus 4y plus 16 equal to 0. Now taking out the common factors, I will take y. It will be y squared divided by y is y, plus 4y divided by y is 4, plus here what is the common thing here? 4. y squared divided by, sorry, 4y divided by 4 is y. 16 divided by 4 is 4, equal to 0. Now these things are the same, so you factor it out. Y plus 4, y plus 4 equal to 0. These two, that is what we have in the second bracket. Since both of them are the same, so we can just say y plus 4 is 0. So y, when 4 cross the equation, is minus 4. So factorization is the simplest way for solving quadratic equation, but the only problem is that factorization does not work for all quadratic equation. Factorization only work where b square minus 4ac is equal to 0, or factorization only work where b square minus 4ac is equal to 0, or b square minus 4ac will give you a perfect square. So that's why I notice that we now have other formulas like completing the square method and quadratic formula, because factorization cannot work for all. There are some equations that now involve decimal. Though let me say it works for all of them, but the problem is, can you deal with the complex decimal number? So when you start involving irrational numbers, as we did in the last class we saw, you no longer, factorization become more complex and sometimes no longer necessary. We now move to the next mode of solving, which is quadratic formula and completing the square method, which is what we are going to do in the next class. But before we close this class today, let's solve one more example to refresh our memory for call it a day. So let's solve this number I of 3, exercise 3a. Mind you, whenever you have equation, try to bring it back to 0 and follow the order. The one that has square will be the first, followed by the one that have coefficient of 1, followed by the constant. In this case, this is not equal to 0. To make it equal to 0, we'll bring this one to this side, bring that one to this side, and now both of them are positive. When you bring it, they will come with negative sign. So this will be b square minus 31b minus 22 equal to 0. Here now, our a is coefficient of b square, which is 3. Our b is minus 31, and our c is minus 22. So then we'll now do a times c is 3 times 22, that's negative 22, which is minus 66. Excuse me. Then our b is still minus 31. So the first thing we are going to do is to look for something. I think I missed this thing I missed this theory in the theory I gave to you. This is actually 4. In a case where you have, let me add this one here, you have x squared minus b x minus c. In this case now, you see that both b and c are negative. I think I did the one where a and b are negative, b and c are positive, and b is negative, c is, and this one. So I missed this one. Thank God we solved the last equation. If not, I would have missed it. In this case where you have both negative, the solution is that the smaller one will be negative, while the bigger one will be positive. You see, it's just a reversal of what happened here. Here, the bigger one is one that is positive, while the smaller one is negative. But in the case where you have negative and negative, the smaller one is one that will not be negative, while the bigger one is the one that will not be positive for the two numbers. So I'm glad I chose this example and it made me to add this extra one here. So let's go back to the question. So we are going to look for two numbers that when you add them, you get 31, but when you multiply them, you get when you add them, get minus 31, but when you multiply them, you get minus 66. You can also look for the factors here, because on my offhand, I think I'm kind of lost. You can do 2 divide, you have 33. 3 divide, you have 11. And which other one again? 11 divide, you have 1. So these are the factors of 66. So we'll take note of this 33 here and take note of this 2 here. As you can see, 33 multiplied by 2 is 66. But now we are dealing with a special case. I said that we need to get, where is AC? 8 times C, 6 minus 66. When you multiply the two number, when you add them, you need to get 31. So in that case, remember what I said, when you have negative, negative, the big one will be negative, then 33 will be negative, while the smaller one will be positive, then the 2 will be positive. These are the number. Minus 33 and plus 2. You can always prove it. Minus 33 times 2 will give you minus 66. Minus 33 plus 2 will give you minus 31. I think that proves this last example here. So you can take note of this and use it when you are solving factorization. It helps a lot. So let's rewrite our equation. Our equation will now become 33b squared minus 33b. So now we'll now rewrite this b plus 2b minus 22 equal to 0. Now we have another special case. So let's take the like terms. Here, the like term between these two is, let me say, mind you, there's something I want to, after solving this, there's something I want to show you. 3b. So let me say 3b. 3b squared divided by 3b, I'll get b. Then 3b. 33b divided by 3b, I'll get 11 plus. Here I will take out 2. 2b divided by 2, I'll get b. 22 minus 22 divided by 2, I'll get minus 11 equal to 0. So these two are the same. So I'll take it b minus 11. I'll take the whatever I have outside. 3b plus 2 are equal to 0. So either this or this is 0, so that when both of them multiply will give you 0. So if you solve for the first one, b minus 11 is 0. Therefore b is, when 11 cross equation, 11. First answer. Second answer, b, that's 3b, solving for the second one, plus 2 is 0. So 3b is, when 2 cross equation, minus 2. So b, divide both sides by 3, also minus 2 over 3. So in this case, let me also highlight this. B now is equal to minus 2 over 3 or 11. You can put this inside the equation and see that it's correct. Now there's something I want to just touch here. Coincidentally, the way I arrange these two usually work out for me when I want to take out the like terms. Let's assume this same example, someone did something like 3b squared. Instead of putting minus 33 first, he now put plus 2b minus 33b minus 22 is 0. Let's assume we have a case like this. You know, when you want to take out the like terms, in this case, the only like term this has and this has is what? B. And you now say b in bracket 3b squared divided by b, you have 3b. 2b divided by b, you have plus 2. Then second one, let me assume I take the like term of 11 here, 11. I now have minus 11 outside. 33b divided by minus 11, I'll still have 3b. 22 minus 22 divided by minus 11, I still have plus 2. I don't know if you're following. So now we have this as common this thing. Now you now have 3b plus 2. The other one, this is b minus 11. B minus 11. You can see that we also have this. It's the same thing we have here that we have here. So I just want to highlight this so you will not be wondering what if you didn't get the correct arrangement. Anyhow you solve it, you will still get the answer, so long as the factorization can be so long as the quadratic equation can be factorized, unless in cases that you can't factorize, where we use the completing the square method and the quadratic formula to solve it. Those are the cases. So this is what we are going to do for this class. We have already summarized quadratic process and how to solve it, and this is a hint I gave you. This hint always work. And finally, I also want to remind you that factorization method does not work for all quadratic equation. There are some places where the root of the equation becomes irrational. In that case, it is not advisable to use factorization method. Thank you, and see you in the next class.